Sir. I want to invite Nilesh Waghela and Chetan Hirapara. I welcome both of you, Chetan, Nilesh. Chirag, everyone already had an introduction in the morning. Okay, so I'll not reintroduce him. I'll give introduction about Nilesh Waghela. How many of you know him, first of all? Okay. Yeah, I know he's famous. And the reason behind that, right? All of us know that almost 3 decades of experience in IT, right? And his contribution towards community building and everything in Ahmedabad and around, right? It's means all of us know that how much hard work he had put for that. So we are really excited, Nilesh, to have you over here. Then how many of you know Chetan already? Okay. So I know that Chetan is also a community builder. He is also helping community, okay, on his research and his work on data science, okay, and AI, ML and everything, right? So both of them need no introduction any further. So the discussion which we are going to have today is more about AI, ML, infrastructure, and what are the challenges around infrastructure, cost mainly, right? That what enterprises are facing. So that would be our panel discussion today. And now I have to introduce myself as well, as I'm going to be there. So I'm Tejas Purohit. I'm VP of Engineering in Prama and FinOps, and I would be the fourth panelist. So thank you very much, everyone.
I should have, can you guys hear me? I should have done introduction for Tejas, right? He didn't let me. That's okay. But Tejas has also something very similar experience, 2 decades. He's been doing a lot of work, especially since he joined us in Prama, a lot of engineering related teams work, identifying, that he started working with one of our education clients, but then started working on the phenomics and like other, client side of things as well. All right, so let's get started. So I wanted to set the context. Who pays for the GPU is the main topic here, and actually one of the person here in the crowd itself asked that very same question: who pays for the GPU? Everything, as we know in AI, right, it requires additional power, and that's why instead of CPU, you need GPU. Although there are options available now that also runs on CPU, and soon we're gonna have our phones also running AI, right? In some cases it does, but the thought process about who pays for GPU, the idea is to talk about like different categories. Specifically, the FinOps is a very well-known thing. But to establish our ground, specifically for AI, let's start first in the journey from cloud, right? And Nitin is our our panelist, and the first question that goes to him, what he sees from cloud perspective. He has been doing AWS community building. I was talking to him in the room. He's been working with AWS since 2012, right? So it's been a great to have someone like that from their experience. Let's share what are the shifts that he has seen in cloud and specifically AI side of things. What all, if you want to share, like the shifts that happened, and then AI coming in, how is that changing the paradigm?
Yeah, first of all, thank you for inviting me. And this is a nice gathering. So let me put my view on, the journey started from cloud and then AI. So when we started, cloud was very new, and slowly and gradually people started adoption. And still, I believe cloud adoption is slightly limited to the dynamic companies or something which is very critical. So I believe if you have something like critical security, scalability, performance, reliability, and then we're going to discuss cost also, right? So if these are some critical things, then probably cloud make some sense. Uh, just for example, if you don't care about downtime, why you wanted to go for a cloud? I'm afford 1 day, 1 hour, 2 hour downtime. I'm okay if on premises. So something is critical, you cannot afford uh, all these parameters, then cloud make much more sense. And nowadays business are there which required almost zero tolerance on all these parameters, correct? You can't afford like Google or Amazon or Microsoft, they can't afford if their services are even stopped for 1 second. So people nowadays, that is not rocket science, you can do that with the help of this cloud technology. That's why everybody attracted to the cloud, and new business or something new started. Typically, it has boosted that startup ecosystem, because now you don't require to invest a lot of money to start with. Once you start your journey, we are discussing like આપણે કદાચ ગુજરાતમાં કે ઇન્ડિયામાં એવું છે કે આપણે જમવા બેસે તો થોડુંક આપણે ગાયનું અલગ રાખીએ અને કૂતરાનું અલગ રાખીએ અને કાગડાનું અલગ રાખીએ એવું કંઈક રાખતા હોય, રાઈટ? So that sense, you have to pay some extra to AWS or any cloud because you don't have experience. Or whatever experience you have, because you are starting, you have to pay more. That's something everybody burn their hands. So that extra cloud cost you have to add initially, but eventually you will learn, or maybe you will get some help from the third party. Those parties have better experience, so you can get help from them, and you can save certain money which you can invest into either maybe manpower or something else, or maybe research R&D. With introduction of AI, again there is a problem, right? Everybody wants GPU. GPUs are not very costly. It's multiple lakhs, even sometimes in crores also. But if I wanted to experiment, what is the alternative with me? The only like cloud per hour or per day probably I can experiment. We don't know what will be the outcome. Eventually, that's what I believe. But still, you need to experiment, otherwise you will be behind the race, right? So yes, everybody is putting money into the GPUs to understand how this AI works, as well as what outcome becomes AI can give us, which will be converted into something makes sense, in the sense business decision. As of now, everything works on perceptions. I don't see much of tangible output, but it will be eventually. We have to experiment something. So that's what first comment from me.
Cool. Tejas, do you want to take up on the next one? Um, and then we'll go in this way, and then we can just start, yeah. So specifically on extending the GPU talk, as we know, right, every time when there is an API call, it used to be like CPU, there is a consumption of CPU. With the AI call, as we learned like about AI gateway, kind of do a model routing, and there are different models that are running. From the FinOps standpoint, specifically from the when it comes to cost, every single call is going to convert that into some GPU cycles. So for the GPUs that are already paid, it's okay, right? But the GPU that needs to be paid, or you need to scale that is the next level that people are thinking. But the first problem is the GPU scarcity that we have currently in the market. So if you can talk about like how do you see as the organizations are adopting to this AI, where these GPUs are coming, why the GPU cost is high, and if you can elaborate like what do you see in future about the GPU cost?
So first, I think what you mentioned, right, that the scarcity of GPUs, right, that why we are observing that.
Mm-hmm.
So what I observe, okay, that majority of the enterprises or organizations, okay, who are getting on board on AI, ML or any operations, okay, which need GPU, whether they are really doing it that they really need it, or it's just FOMO, okay, that yeah, means if we don't adopt it now, right, then maybe we will be left behind. Because if we see the researches, right, that return on investment, it is not matching that if everyone is using GPUs, right, and it's generating this scarcity, right, but those investment and the return of investment, okay, is not what they are getting. So it's basically, I think, first of all, enterprises, yeah, larger enterprises can afford it, right, and they have budget for it as well. But smaller enterprises, okay, who start it without thorough planning, what Ronak mentioned in morning session, right, that data, they sometimes start without a proper data management or data modeling or anything like that, right? They already started investing on GPUs. They started the cycles and everything, okay? And later on, they experienced that, yeah, we had started it wrong, right? So I believe that scarcity is there, but it can be managed if it would be used appropriately, first of all, with proper research, right? And the cost of every transaction which you mentioned, right? So enterprise level researchers, okay, they are actually thinking at that level right now because they are planning their budget in such a way that whatever penny we are uh, means definitely investing in that, whether we are getting that result or not, right? So once they start figuring it out, okay, I think that organizations, those who are not thinking on that level yet, okay, they will be start using these GPUs and whatever cost involved to it, okay, very cautiously. Because right now they are not experiencing that, okay, that if we are burn it out, okay, without any plan, okay, then maybe once you learn everything, that now I know that how to do it, but now you do not have budget left, right? So that's what I think. We are still in learning phase, right? And that learning is going on, and once we will be stable over there, okay, we'll get that result return of investment, the cost per transaction, because I don't think that majority of the implementers are yet reach to even calculate the cost of transaction as well. They don't even understand, okay, how they can calculate it, right? And basically at that time, FinOps can help, right? At least an infrastructure level, that whatever infrastructure you are having, right, how much you are spending on it, how much transactions have been made, okay? And based on that, if they can come up at the granular level, right, to calculate that cost per transactions and all those things. So yeah, it will happen eventually, and with all the research and all these things, okay, will reach over there. That I would believe.
Good. So we'll ask some tough question to Chetan. I know that he can answer a lot over there. Specifically on the AI side of things, Chetan, you have been working on AI side of things, specifically, even the mid language model, right? Like SLM, MLM, LLM. And so in your view, practically when you deploy these models in production, right? Specifically from the cost perspective, what do you see that organizations need to do in order to capture the cost aspect along with the usage, and how they can correlate both of them?
Okay. So that is very nice question. Uh, Most of time, what I have seen that many people are using GPT 5.1 or some reasoning model for just doing some translation, sometimes sentiment analysis, right? And these are the mostly usual problems in the phenomics, right? Even in the e-commerce, people are doing sentiment analysis, raw views, recommendations. Many times, even you don't require that kind of model. Small language model can efficiently run even in the CPU. You might be know about ONNX runtime, right? So up to maybe 10, 20 GB model, any Hugging Face model, you can take it. There is ONNX Optim library. You can convert that model from GPU to CPU based, and you can also run the same model in maybe 16 GB RAM CPU machine as well. So it is a 10x or 20x cost saving, right? And especially in such kind of banking and financials where you don't require the latency, right? You maybe run something in the batch processing, you definitely should try this small language model rather than burning the GPUs. Second, many times I have seen that people taking the latest. So in the AI, there is a FOMO. So if Anthropic has released 4.8, why I am left? I haven't tried that. Let me try it out, right? But first you identify whether you really need that, right? Since 4.7, 4.8 release, most of people are still love 4.6. That was past model, I guess 3 4 months back model, but still it is efficient to doing all these things, right? then you no need to do other experiments when you have efficient model, right? Why you are burning your money? So suppose there is Hugging Face model, something new models is launched in QN 3.5 or whatever. So people just try to take, let me take one GPU and let me do some experiments. But the same thing, the same GPU can also shared across the other teams as well, right? It is not required that you are going to definitely use it 100%, right? If you are taking 64 GB H100 NVIDIA GPU, it is nowhere going to utilize 80% even, right? So what you can do, you can share that instance with other teams as well. So why not sharing that cost between other teams and run that, right? So in the industry perspective, first we have to identify what kind of use case we have, and according to, as I said, small language models is perfectly running fast as well. Okay, so take the small language model. If it is not, see, in the reality, enterprises don't require a text generation model, right? They, what are the use cases are generally around this thing only, right? So also all the topics, labeling, identification, fraud detections, right? So it's not required that every time you use GPU models or LLM models.
Excellent. I would appreciate everyone if they can maintain silence. I'm hearing some background, so thank you. Um, I have a question for Nitin. You know, coming from the cloud background, right? Specifically, what you see as a shift that, you know, organizations are using infra level things, right? You saw that infrastructure as a code is being written. When GPUs need to be used for this different workloads that organizations are using, how do you see that from, let's say, a cost is paid $1,000 a month for a company, and you want to track it, and but also next phase is to reduce it. So how do you see that, you know, teams can take action in order to use it? They go for a third party to third party company. Do they have anything in AWS, for example, currently that can help them do that?
So this is typically FinOps question. So what, I'll start with very simple things. Uh, Sometimes, recently it happens. One of the case, like, one of the companies say, I want GPU, just give me price of GPU. So I'll say, what is your use case? It is training or inference? So I did not got any answer. So I tried again, okay, what is your use case? So probably he don't know, like, what is the use case? Okay, both. So that was the answer. So what I understand is probably we required something, before FinOps also, we required something whether this application required GPU or not. Because everybody wants GPU, right? Let me try some GPU. Eventually, once we have a meeting, we come across like a very small application, they don't require GPU at all. But everybody, people will don't understand what I required for training purpose, what I required for, inference purpose. So both have some different, requirement, and as well as, application also. So first we need, probably if you have some application, we need to understand what kind of, GPU or what kind of things we require. Whether we required, it goes for training or it goes for inference, right? So that is the first thing. So once somebody will try to design some application, we need to understand whether how much portion of the GPU or, kind of a generative AI required. It might happen your application required 10% only, because you still required something else, right? Authentication you required, some database you required, something you required. The whole application not be just generative AI. You require a lot of things. Even GPU, right? GPU also requires some computer to be attached. It is not alone GPU will not work. So GPU required, I understand that. But we need to understand first step is how much. That awareness is very less actually. And that I don't think there will be any best practices, standardized best practices are there, which is there in cloud as of now. And we have architecting best practices for solution architect, in the sense well architected framework. It is there for the cloud. So you can understand like how much standard practice I am doing, whether it is, for cost, whether it is performance, whether it is, reliability or security, whatever it is. But that is still, standard is not established. Uh, Standard in the sense people are doing different way. I don't say that's not a problem, that is a problem, but still standard is not there. So I think better to rely slightly. If you don't know, try to rely on third party. There is nothing wrong into that. Somebody is providing like whether my application required GPU, so go for that. Nothing wrong into that, right? And once you understand, you can easily change afterwards also, right? It's not like you tied to do that. So with the help of AI, I'll take my view on different way. Uh, FinOps, I don't think for GPU it is very well exist. A lot of people are trying. Who is right and who is wrong, we don't know. But we have to trust someone and you have to try something, at least you before spending some money, right? After Probably after sometimes you come to know this is right or wrong. So you have to try. It will save a lot of money. If you don't understand how it works, then try to rely someone. Try to check whether they are good or bad, and then probably you should rely on the third party person or company. So that's what I believe, because yet the standard will be established about GPU based application. There will be, but there is no standard kind of thing like in well architected framework. It's standard, right? It's across the cloud you can use that. So that is very well established standard. So GPU probably some standards should come once like everybody come together and standard will be established. And with the help of this kind of application, a lot of things can be thought of. Specifically, I would like to mention maybe very short something called digital twin that will help us a lot into in future for typically training purpose. You don't require to go somewhere else. That you can do in virtual world, and you can save a lot of money. There are some extreme conditions that you can't go. Let's say space exploration, Mars, even moon. Even in our case, some furnaces are there, or maybe Antarctica will be there, or even ocean, yeah, deep into ocean. So all these things can be uh, available with the help of digital twin, which will save a lot of money. Though we don't require that much AI into that, we require GPU, but not AI perspective. We require GPU slightly on graphics perspective, which will be fast calculating purpose. So I think generative AI will be there and going to be affect a lot. FinOps perspective, I believe we require to rely someone, because most of us, 90% us, don't know whether my application required or not. And once I start, what are the best practices? So I think until unless we know, we if we don't have knowledge, we have to rely someone, those who have knowledge. So I believe we should be using third party or third person, somebody who is already knowledgeable. That will be better.
Thank you, Nitin. Yeah. So for Prama, we have a customer who is working on the government projects, right? So they decided that the GPU need to be on-prem. Now, when you have on-prem GPUs, you have a totally different problem than what you have from cloud. You need to think about installations, plugging in the GPU, all the way to running that application, whether it's inference, training, whatever that we have. But the bigger problem there is cost, because you plugged in your machine, right, in GPU. Now you have different environments, because people need to test something somewhere, right? If you directly do in production, it's not going to work, right? Otherwise, everybody is saying, yeah, I'm testing my code in production. So when you have the GPU in the pre-production environment and you want to run it, you cannot have multiple environments. So you have a dev and you have production. That's actually very able to manage. And in some cases, some customers are not even able to do that. So looking at cost perspective, when we have to create these multiple environments, what do you suggest from the best practices perspective, that how we control the GPU cost for the pre-production and then production? So either Tejas or Chetan want to go ahead.
So, first of all, as Nilesh mentioned, right, that how to monitor the cost, right, first of all. Now, investing in GPU hardware is one thing, right, that you already invested lakhs or maybe crores, okay, for that, purchasing it based on your need, right? Now, how much utilization you are doing? Because if you had purchased something, right, and you are hardly utilizing it for 10%, 20%, as Chetan shared, right? That if you are only using it for 50%, then rent that 50% to someone else, right? Or maybe share it with someone, right? So how to monitor that, how to do that, and that's where I think FinOps comes into picture, right? That you start with something, because obviously FinOps, you basically first of all understand your requirement, right? That yeah, on dev environment I would be requiring this infrastructure, on QA I would be requiring this, on pre-production or UAT I would be requiring this, and on production would be this. Then you ran it for 1 month, 2 months, 6 months, right? Now at some point of time you need to check the utilization, right? That whether you are overutilizing it, and do you need upscaling, or you are underutilizing it, right? And maybe you can either downsize it or maybe share it with someone. Those decisions can be made only on data, right? And unless and until you do not have that data, right, that decision, as Nilesh mentioned, right, that you have to rely on someone, right, to expert. So that data can be uh, need to be studied, right? And once we study that data, it will give you some pattern, right? That yeah, your utilization is you are underutilizing your GPUs. They are more capable, okay, than what you are using it, and you can generate more revenue out of it, okay, if you utilize them better, right? So there would be some scope, okay, if you know that I'm only using it for 50%. I have 50% capability, but I'm not using it. I can have more projects because I already have that hardware, okay, but I'm not utilizing it. So more opportunities open for decision makers, right, once they have this visibility. So that's what I believe, that yeah, you start with something, understand your requirement, understand your business, okay, and then study the data, okay, that how much you are utilizing it, right, and then make adjustments accordingly. Either you increase business or maybe downsize the infrastructure, whatever makes sense for your business, right? So that's what I believe. Okay.
Yeah, so good question. Like, if you have a dev and prod two versions, then no need to clone the everything, even the GPUs, right? Mostly nowadays people are using GPU for LLM models. So when you planning your inference engine, right, by taking any open source model or fine-tune model, first ensure that what type of applications you are running and what scalability you require, and according to that you can select the framework to deploy that LLM into GPU, right? So there are two or three well-known framework. One is VLLM, right? So VLLM you should definitely use in the development environment where you don't require the scalability or Kubernetes and multiple pods. Where you require this same thing in the production, in that case you should use TensorRT. So TensorRT is Google based framework and it is directly supporting Kubernetes and all. So you have to also take this decision. No need to clone everything, right? Just because in the development environment there no need, not require the scalability. It is for development purpose, testing purpose. When you go production, you should also switch the gear in these cases to save the cost.
Let me. Yeah, you want to please go ahead.
So uh, in this environment, cloud make more sense. Reason being, a lot of monitoring tools available, whether you use CPU, GPU, or whatever. So you have logs, you have monitor metrics, and some expert can make some sense from that. So I think cloud make more sense. Otherwise, what happen if you bring GPU at your on-premises? You have to establish everything again. You have to use some Grafana or maybe something else. You have to establish it. You have to trace the metrics. You have to find out the logs. A lot of other things. So cloud make more sense because they will give you most of the things default inbuilt. So that's why you can understand, like, what is my behavior of usage behavior, and I can make some probably data aware decision, right? So that's what I wanted to add.
Actually, that was my next thing as well, as a segment that we move. Um, where should we deploy the GPU, whether on-prem or cloud? And that was a best way to basically start that section. Um, as we discussed, some on-prem perspective, you have privacy, security, you have more control. But then you are also worried about, hey, if my GPU is basically currently X version, and then you are getting outdated very soon, right? In cloud, you don't have to worry about it. There is a new NVIDIA chip, that is cloud problem. But then you are also paying premium price for that as well, right? So comparing that, let's talk about like what are the pros and cons, best practices that we want to have when we select, from that. And as a developer, you know, when you are working with this, either of them, on-prem or cloud, which one makes it easier? Let's discuss that. Chetan, if you want to start.
Yeah, so definitely as a developer, if I am not looking the cost, then obviously cloud. But if my GPU is there, it is going to run 24 by 7. I have free hand. I can do anything, right? So that is also good point in the on-prem. We have some on-prem client, especially in the finance and government sector, and we have free hands. We can do anything on that without worrying about cost, tokens, right? So it is really make feel that no worry about the costing. GPUs anyways is going to run 24 by 7, right? So if you have to do more experiments in free hands, then definitely on-prem is a good for developers.
Um, on the next question, right? Specifically, when you look at the on-prem, you are saving the cost. On the cloud side, what are the, so you mentioned about VLLM and TensorRT, some of the frameworks for deploying in production. Um, Managed services for AI, like Bedrock, having already fine-tuned foundational models available. When it comes to GPU cost, right, which one is better? Is that we should use the foundational model, or we should use our own homegrown, or like, get from Hugging Face and like, just make that working? So let's talk about, even over there as well, like which approach we should choose between the two.
Yeah, so in Bedrock, everything is very well prepared, managed for you. Template is ready. You have to just pick the data set, pick the model which you want as a trainer model, and pick your data sets where you want to dump into the S3. So everything is ready. So you have to just do this setup. You have to make golden data sets, and that's it for SFT fine tuning. Where in on-prem you have to do everything by yourself, but it is not that much of difficult nowadays using Claude and this vibe coding tools, right? You can just preparing the data set, that is a difficult part, but writing the script, it is hardly 10 line of code to do fine tuning of any model, right? And even in the cloud version as well, when you have your domain specific data anyway, you have to create that Gordon records. Otherwise, there is no meaning of fine tuning the model. So both way, for me, I would say that both are easy, even in on-prem or in cloud.
Probably take one question from audience, just so that they can focus more, because I still hear a lot of background noise. So any questions that you want to ask, and then I have more questions, but we can keep on going. Any question that anyone has? Now there is a silence. That's what I was expecting. And the question doesn't necessarily need to be related to GPU costs. I know there were a lot of questions about AI, inference, using agents. So feel free to ask any questions around that as well. Okay, just not setting the ground that you only have to ask about GPU cost. Agents, yep. Mm-hmm. 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 Yep. Yes, I was thinking the same.
Yeah, so this is very specific AWS question. So I say yes, you should go for that. But the approach will be once you create an agent, one agent will, you have created the agent, it will create, permission, uh, the set of policies, right? So second agent you should create, which is kind of, validation. It will create a mock kind of environment. It will validate that whatever the result we want, it should validate. So that's why you are reducing a lot of hallucination. So I think one is creator, second is validator. So validator will give you, very good understanding. Everything works better. So I think this should be our approach, and you should go for Bedrock actually, because you are into AWS, and AWS should understand AWS very well, better actually. So you should rely on AWS, Bedrock, but with some caution, kind of validator. So create one validator agent also for anything, not only for permission. Whenever you build something, how do you confirm it works? So let AI do that. Once you create permission, it will validate also in mock system, kind of mock environment. Okay, this is permission applied. Now what happened? Does it hallucinate, or it is less or more? So it will give the result, then you apply.
Your specific question, what are the agents you are mentioning, Amazon strands, or it may be have MCP, you can write hardly 10 to 15 line of code that is a layer or wrapper on top of that. So Amazon strand agents or MCP is giving 100 tools. You exclude those tools, those are risky for you, right? So there is a tools exclusion as well. So you just exclude those tools in your wrapper and then you can freely use your code. Did you get my point? Yeah. Okay, so might be I'm not aware whether there is a guardrails or exclusion or some parameters are there. But what are the tools you know you are talking about? Just ping me that name. We can check. Okay, got it.
So I think Amazon Q is kind of a wrapper on top of all of that, right? So if you look at AWS Run, you can first ask Amazon Q for the best practices that you need to follow when you are running AWS Run. Specifically, the guardrails would be like which type of account you want to run in. Let the system identify whether it's pre-production and production, and then put more guardrails, like Chetan mentioned about certain tools, right? So there is a policy that you would have for each tool, what they are supposed to access, what they are supposed to do, and sometimes also put in, like, don't let the tool do whatever they want, right? Otherwise you will run into problem. The one that we talked about, Replit, right? It created a huge mess for the Replit. Production database went down. So those type of things, you have to keep that in mind when you are having a free tool like that that can create any number of instances or make any changes in your infrastructure. Always keep that in mind from that perspective. Good question. Yes. What FinOps metrics that AI for AI that everybody. Correct. I can start, and then you guys can basically say. So we, because Phenomics is working specifically on this, primarily first thing is your tokens, the inference points that you are having, and the GPU utilization. Now there are libraries, if you are talking about on-prem versus cloud. The cloud, you have to rely on what metrics is being produced by, whether you are using Bedrock or you are using your own cluster. If you're using Bedrock, these are available, right? GPT model or Claude or any other model, you can basically extract the token information, and then you can track that and map it against the cost. If it's GPU, how much GPU has been used? There are NVIDIA packages that need to be installed that gives you that output. Expose that as a metric, and you start using that as a metric to number of queries that are coming versus the number of tokens that, or basically the GPU that you are consuming. Because one of the problem is GPU need to be packed, right? If you are having one big GPU, you just cannot use it for your one task, right? The idea is to share the GPU, and GPU sharing is an art, right? Because Mistral type of model, which are like, 7 layer type of, you have multiple layers over there. Each layer basically gets in, and then you start having that inference going over there. When you have that level of details coming, right, you want to make sure that those metrics are retrieved, and then you are watching them for packing the GPU with multiple inferences that are possible there. So I would say that would be the good start. And the tokens, of course, is becoming commodity, right? Like, you have input token, output token. Let's consider the hosted model, like, um, if you are using GPU specific model, then you start having this metrics pulled out. You need to do work for that. If you're using Bedrock or any of, Vertex AI, the Azure Foundry, for example, all of these guys, they have their own metrics based on the model that you are using, and use cases are also different. For example, you have image use cases, you have video use cases, you have text use cases, you have rack pipeline going on. All of these are all different use cases, and they consume different types of model need to be deployed, and they consume different types of tokens as well. So which use case is consuming what tokens, you need to have a mapping for those. Anything else you guys want to add?
Uh, that was perfect. Few addition or adding a few points actually. Uh, what you need to do is, for my perspective actually, 2 points adding to this. This is perfect baseline. First is, yes, that token. But then you have to identify, once you input token something, try to use something. If your application support, try to use cache, right? So your query will not go to the LLM. If the query is coming from cache only, that will save a lot of tokens, right? So introduce cache and monitor cache also, like how much cache will be performing, and how actual query go to the LLM. So that will save certain tokens, as well as give faster result. So I think you should monitor cache also. So that was the first thing. Second part is, sometimes some of the queries, we don't want to, you have to categorize the queries. Uh, what kind of query is consuming more token? Highest, like database. Like some of the queries will consume more or take more time, as well as take more CPU. Similarly, what kind of categorize the query? Like what are the queries are taking more tokens, input, output, whatever, and categorize mid, uh, kind of very small, mid, and large. So based on that, you try to optimize it if you have that matrix, that what are the category we have, and based on that, some of the query can be optimized, and you can reduce your, token consumption. So that will be, these are the metrics you are supposed to, take care.
What Chirag was mentioning about evil framework. So most of we guys know about drag, but there are other evil matrices as well. For example, you are building a SQL generator, right? So in the SQL generator, there is a query optimization, what kind of query LLM is writing, right? Suppose you are saying that, hey, give me all the users, and you have 1 million users in your database. What will happen? Your context will flooded, right? So that kind of matrices should be also included, and when we writing the code, we should also ensure that my query never adds star, right? Many times, wherever the open-ended is there, then always your follow-up questions from your chatbot that, hey, are you looking for specific user, right? Or specific city or specific countries, right? So always make sure that if you are running on the SQL generator, there are proper evolution metrics set. If you are working for web search, then proper number of websites or proper number of allowed domains is set, right? So these are very important things as a developer when we are building application, that is included in your application.
Sounds good. So I think we have spent good enough time in terms of discussing GPU. There were other non-related GPU related questions as well. I think we should move forward with like the next section. But before that, I want to take one last question. Yes, Dheeraj. Very hard to hear. Yeah.
Hello, can
Yeah.
you hear me? Yeah. So basically, general users, right? So they are like certain percentage of users who are basically using the platforms, the Chat GPT or Cloud, anything, right? Locally. So they are referencing your their local data, right? The local paths and everything around it. So we have not discussed about the security of how we are using this thing, right? Are we so there are like latest things that is going on in market, like related to Docker, sandboxes, right? So how we can use these things to securely use AI models or things as a developers or as engineers locally to experiment with these things, or also the MCP tools, right? That we can have in the sandboxes. So what are the configurations or the things that is happening in current spectrum, like okay, how this is moving on, right? So what are your take on this, right? So that's what I wanted to know.
Question. Recently, I will share one of the last week experience or incident. One of our client was creating on Azure VM, and he installed Claude and Codex, everything inside that, and dumped almost many of the data files, and he was doing experiment. Unfortunately, Claude installed one bin file inside that VM, and then bin file has started exposing all the code, all the files and everything, right? So that is the sandbox environment, and he was trying all this experiment, and he switched the context. He stopped that codex and switched to Claude, and Claude has detected that there is one bin file and it is exposing your data through different IP address, international IP addresses. So whenever you work any kind of sandbox environment, ensure that all the outbounds and inbound rules are stopped. Also the ports are blocked, right? Unknowingly, maybe Codex or Claude may install such kind of binary, and that can expose all your configurations, your IP coding as well, right? So whenever you do such kind of things, ensure that all these things are on place. On top of that, never place the data and computation in the same bucket, right? So data should be outside of your computation. You may lose your company's confidential data as well in such kind of incident, right? So that is very needs. That is the thing that every developer should be taken care. So Claude and Codex, that is a God gift, but ensure that that God gift will not lose your company's credibility.
Last piece from my side. So there are tools like Olama, right, that you can install locally. You can try a lot of these models locally. If you are want to just experiment, especially if you have MacBook, it comes with the GPU inbuilt, right? So you can experiment with this thing. The other is if you are CPU bound thing, there are CPU based models as well, but the accuracy as a developer that you would expect is not there, right? GLM is a great example, right? There are these models that you can run in GPU can also run in CPU, but just that the inference won't be that great, the accuracy won't be that great. So from developer standpoint, I don't think so the models are there yet, but it will become as we go, right? Like specifically, like I'm looking at only GPU specific thing, right? Like, okay, I want to generate the code. Instead of going for GPU, let me go for a model which only does codings related stuff, but only for CPU specific task, right? So as long as that model is small enough where it can fit into the memory for a computer like MacBook, I think we will get there, right? And as we go more and more, like the model will also become smaller, right? Like we started looking at purpose driven model, right? So we're gonna have those type of models more and more coming out, just like the way agents are coming out. Right now the companies are focused only on the applications rather than the GPU cost and stuff. They want to just be ahead in the curve, right? So but good question, Dheeraj. Thank you. Anyone else wants to add anything?
For security purpose, I think in normal security, I'll just give analog. One is host-based security that you install in your laptop, and second will come, network kind of a security, which we'll consider as a firewall or web application firewall. So nowadays, both are available. Host-based also AI firewall as well as network-based firewall. So you can rely anything goes outside of your organization. It can detect. You can configure like what kind of data you don't want to go outside, or you don't want to. Maybe you mask also. So those kind of things available. So try to use that in case like your data is very important and you are communicating to internet or maybe third party tool. So that is something what I suggest. Last thing I would like to share from my side, GPUs are very costly, not easy to handle. You might be surprised. One of the private cloud provider in India, which is top or comparatively very cheap also, they have 28% failure of GPU. So once you submit the query, chances are there GPU query will fail, right? So don't consider if your cluster of GPU will not fail. So consider that failure part also. 28% is very high, means your 3, 4, 5 days will be increased. The time will increase because it's failed. You have to create checkpoints and again you have to start from that, right? So consider that it's not easy to manage cluster. GPU query, once you submit, it can fail also. So you have to understand how to create checkpoints also once you are training, right?
Okay, so I think I would conclude that as a, I appreciate, there are more questions that people want to ask. Let's take it offline. We are running out of time. I'm already 5 minutes late and I'm being told like no more questions. So sorry about that. But we would love to take these questions offline. All the speakers are available after this session as well. One thing that I want to just summarize as a concluding thing, right? GPUs, as we know, all the organizations are trying different things and they are learning along with what's happening in the market. Like India based companies, they are also doing GPU production. Nvidia is one of the basically pioneer and has been doing this, right? They are also planning to send the GPUs in space, and we have also looked at that. So having that control of the GPUs from the from your inference perspective, from traceability perspective, as well as from cost perspective, all of those three, essentially if you focus, it's ROI. How much is your return of investment, right? We talked about this, but most importantly you need to keep that in mind based on today's discussion, what GPU costs and how much, what your revenue it's generating. So with that, I would like to thank you for the entire panel. I appreciate all of you guys being participating on that, but I appreciate it. Thank you.
Sorry. So I would be back to my role. So Chetan, I want you to on stage. Nilesh, we want to give you some goodies for this. Okay, so I'll invite Ronak uh, and Rushikesh for, please.
Where is my gift?
So thank you very much for this discussion. It gave really good insights, okay, about especially GPU, okay, and all the best practices. There are a few very good questions as well, okay. Now we'll move to the next segment, okay. Uh, our team of developers, they are going to present uh, LLM models and everything, okay, that how models evolve based on the needs, based on the best practices and all, okay, and they had also prepared a very good demo with business use cases and everything, so it would be very exciting and insightful demo. So I want to invite Yagna, I want to invite Dhairya and Fanil on stage, okay, so for this demo.
First of all, thank you, Tejas, for inviting us, and good afternoon, everyone. I hope you're still refreshed and you still have energy. So, without wasting any time, let's get started. So, in this key session, we'll be discussing the transition from the CLIP model to the GPT-based vision model and how we can use it to solve industrial-based use cases or problems. And one such use case that we'll be looking into is how we can identify damaged products and segregate them from the normal products and how we can stop them or avoid them from reaching the consumers. So more on that later. For the next part, I'd like to request Fenil to give an explanation on the clip architecture. So over to her now.
Thank you, Agna. Before I get started with the clip, I would like to know how many of you knows YOLO model? How many of you have used YOLO? Uh, can you tell me why is it used for? What is it made for? Any of you? Yeah, please. Right. So, yes, please. Object detection. Perfect. So for object detection, we have different classes. In YOLO, we have 80 plus 80 classes, like multiple, say, vehicles classes and some objects like that. So one major problem in YOLO is what? It is limited to 80 classes. For if we want to go for another classes that are not present in training dataset, we have to retrain it or we need to fine tune it, and it doesn't understand the textual text data, it just understands the image data only. If we come for language models couldn't understand image data, it's limited to text data only, right? So here we are presenting clip model, that is basically vision language model that will understand both image and text altogether. So the topics that we are going to discuss today are the vision language problem. What is the main problem behind textual and image data? Why it's needed to combine both of them? And what's the clip contrastive pre-training logic that is used in clip models, cross-model retrieval, GPT-4V and cross-model attention, and then we will be giving you a live demo of some projects that we have built using these architectures, okay? Next. So, as I mentioned, what is vision language models? The traditional models like YOLO, ResNet and all couldn't understand text, and some large language models couldn't understand images. So, in the cases where we know that an image, something object or whatever it is present in the image, we can represent the same thing in text as well. So, there is semantic relation between textual and image data, right? So here traditional models were need to be trained every time we have to predict some another object, but clip model resolves all these problems. It is not needed to be retrained every time we need to predict another object, and it understands both textual and image data. It understands the relation between textual and image data. Then traditional models couldn't understand captions and descriptions. As if I say again, image has relations with text. Image can be described in text, but it couldn't understand. So we can't keep image and textual models all together in same space. But clip model has a same embedding space for textual and image data both. Next. So, how the origin of clip came from? So there are two models that contributed to the origin of clip model. One is convert and vertex. So the convert model is basically originated for, there was a use case in medical industry where they wanted to relate the X-rays with reports of that description of that X-ray. For example, there is an X-ray of hand and it has some relation, it has some description, it has some reports of that hand X-ray. Similarly, if we have an X-ray of leg, it has some another description which is not related to hand. So it needs to relate the X-ray with report. So it gave an idea that an image can be correlated with its textual description. Then there was another vertex. So vertex had similar architecture, but it has different goal. Vertex did what? Vertex can create or can generate captions for images. So if I can give image and get captions or descriptions generated for the image, it can tell what is in the image. So both these models contributed and gave idea for clip, and clip combine both of these approaches and can do both of the can solve both of the problems. Next. Clip model has basically architecture of clip model is a single encoder for image. Now you might be wondering what is encoder. So in a simple terms, if I place it, encoder is an neural architecture which converts the textual pixels, image pixels into an array of numerics, basically a vector. And similarly, text encoder, just like image encoder, text encoder converts textual data into numerics so that we can, using some formulas and some cosine similarity as mentioned here, we can understand the relation between both of the embeddings altogether using the very same model. We don't need different models for different type of data. So while I'll be giving an image and I'll be giving textual data, what it would do, it would convert it into embeddings, vector embeddings, and it will pull together similar type of embeddings, whether it is image embeddings or textual embeddings. It will pull together similar embeddings together and push apart different that are not correlated. You can understand it like a universe or 3D space, where if I give an example of solar system, we have multiple planets that are in together in our solar system, while some of the planets are not in solar system but in different universe or different space, right? Because they are not pulled using the gravitational force of each other. Next. So the embedding space that I was talking about, where the image data or image embeddings and textual embeddings. Both are stored in the same place. Both embeddings are placed over together, and so that we can understand relation between text and image. So they are not say treated separately, they are treated similar only. If here we have an example of a soda can, and there's image of soda can, and there's a word embedding, textual embedding of a can. So soda can image embeddings and textual embeddings both are kept together because they are related to each other. Similarly, for image of water bottle and for textual embedding of water bottle, they are placed together because they have relation. They mean similar things. But a rocket, which is not related to soda bottle, neither it is related to water bottle. So it is kept very far away from both of these embeddings. Next. So Clip has 400 million pairs of data, textual and image data. It was trained on a data set present over internet. Unlike YOLO, where we need to use the traditional method of say annotating the data, where there are some competitions hosted, there are some companies pay people to annotate the data, and it is very time taking. It takes lots of money to invest, and it is very slow, time taking, plus people we need to invest our time and people both. So instead of that, we over the internet, we all know that images have metadata or its description present in the internet itself. So what we can do, we can just use the raw images and those descriptions present in the metadata and train the model, and it has knowledge of all those objects present over in the images. We don't need to train every time we want to predict a new object. And it was released in 2021 by OpenAI. It has 70% of accuracy without any kind of fine tuning. And as I mentioned, it has zero labeled examples as it was not annotated. It was basically internet data set that directly used. And for training, how Clip works. Basically, we feed the images and the text data, and then it is converted to vector dimensions, vector embeddings, and then using contrastive loss method, it, as I again previously mentioned, that it pulls apart the similar kind of embeddings, and the embeddings that are not similar, they are kept far away from each other, so that when we have to identify images, that if I am giving a text like I want the images of a can. So in the embedding space, the vectors of cans, different kind of cans are kept together. So when at the time of prediction, what it would do? It would do similarity search and find all those embeddings and give us the images of those embeddings basically. Then comes after training again. Once we train it, we don't need to retrain it as it already contains knowledge of different types of objects, not limited to any of the classes. Clip has a method of zero shot classification for prediction, where we just give image, we give a single label, like a photo of, here label is variable, that we will be getting at the time of prediction. I'm giving it, and the model will encode images and then find out similar images present in the embedding space and give us using cosine similarity, and we'll get top 5 or top 10, whatever we have given, we'll be getting top images related to the text that we have given. And if it works both of the ways. If I am giving image and I want to get similar, if I'm giving text, I mean, if I'm giving an example of I want a soda can or a water bottle, then I'll be getting similar all the images of water bottle. And if I want to generate the text description or like what is it, captions, yes, captions of images, then we'll be getting it by giving the image. So next, I'll hand it over to Yagna, for he'll be giving you more idea of applications of this clip model to in the industrial level, and many more applications that we can use it for clip.
Thank you for the insights, Fenil. Now, as we now understand how the clip model works and its architecture, now we can look into the business cases or industrial use cases of the clip model. So there are n number of manufacturing products that we see all day, but let's take a common example of such packaged beverages that we consume every day. So it's safe to assume that this industry will go on in the future as well because it has sustained. So this is an image of several products that you could see in the market. Let's assume that we have a can or a water bottle or a manufacturing unit that produces soda cans. Now, one major challenge that such manufacturing units face is that they also, by mistake or through any error, they produce defective cans or soda cans or water bottles. And to solve that, there is usually manual inspection, but it is not always enough, and it is not also very efficient. So in that case, we can use the clip model to identify which can is damaged or defective and which one is normal. So to do this, as Fenel explained before, that we can pass the image and the text description of the class to the model. And since it is trained on a very large corpus of data, roughly or even more than 400 million text pairs, it will be able to explain or classify if that can is broken or defective, or is it in a normal condition. So in that way, we can identify and segregate the damaged ones from the normal ones before they reach to the consumers, as if it reaches, even if it reaches to the retailers or the consumers, the cost of it coming back, the transport, the fuel, the labor, all that is just extra additional cost. So it will help us eradicate that at the first level or the first stage of manufacturing, and this will help us save additional cost to the manufacturer. Next problem, can you go back? Yeah, so the next problem that manufacturers face. So once you're done with the manufacturing, the next step is to sell your product. So once you're done, you either want to partner up with a retailer or you want to take it up offline or online as you wish. So let's consider the online setup. Let's say you want to sell it across multiple platforms such as Blinkit, there is Zepto, there is Amazon, etc. And to do so, you'll have to prepare listings of your data or your products. Let's take an example of the soda can. And as you can see here, there is not only one type of product or a soda can that a manufacturer produces. It could be of various types. As you can see here, you guys must have consumed, any of these. So there is not only one product. There are multiple variants, and if we want to assume, you can assume around 30 to 40 products for a manufacturer. And if you want to go further, you can take an example of 5 to 6 variants per product. So that would make up to 200 products, which are discrete. And to maintain the listings, the product listings for each of them, and to maintain them across all the advertising platforms or the selling platforms, that is difficult. So one major problem that these manufacturers or the sellers face is incorrect listings across multiple platforms. So we can solve this using Clip again. This is another use case at another stage of this entire process from manufacturing to the selling to the consumer. So what we can do is we can make use of cross-modal retrieval, where, as Fenel explained before, that you can pass an image and the text, and the clip model comprises of two encoders, one for text and one for the image. What it will do is, it will use the text sentence, it will break it down to words, and there is a transformer model in between. Let's call that a process block for understanding. It will convert that into a numerical representation, and similarly, it will do the same for the image. Instead of breaking it down to tokens, because an image cannot be broken down to words, so it breaks it down into patches, which is basically smaller fragments of the same image. Once that is done, we also have the image representation, the same numerical representation, and then there is a small mathematical calculation which we call cosine distance or cosine similarity. And by doing that, so we'll able to find out the distance or the similarity between both the text and the image. So let's say how we want to solve this problem. What we can do is, let's say you have a catalog of 1,000 products, and in the search bar you type a soda can for Pepsi, or let's say a blue soda can. So what we'll do is, like I explained before, it will fetch all the products of blue color, which is a soda can. And since the clip model is trained on a very large corpus of data, as Fenil mentioned earlier, that it is trained on like 400 million, it is safe to assume that the product or the soda can that you have in your catalog is also trained on that data as well. So it will be able to fetch that data from your data catalog, and you will be able to see the duplicate listings because now the text that you have put in, it has matched with the image. Yeah, next. So basically, this is the process. Like I explained before, there is a encoder for image, there is an encoder for the text, and then what you can do is, since you have a very huge data catalog, you can save it. You can save the representations to a disk or a file, which you can use it every time instead of like computing it every time. So it's more efficient. And apart from this, clip cannot be used everywhere. It has its limitations, about which I'll like to invite Dhairya on stage so he can give a brief about how we can use GPT vision language models to solve this, and now he'll take over.
Thank you, panel, and thank you, Yagna, for setting up the stage for me. Now, first of all, before moving to GPT-4V, I would like to come and brief about like why what clip can do and what clip cannot do, so that it can summarize the points that were already explained by them. So the first point is zero shot image classification. We don't require any of the training images in clip. It is already pre-trained and it can even predict on unseen images. So this is the first point clip can do. Second, it is text to image retrieval. So you give any labels, it will predict, it will take out the cosine similarity and then it will give the best fit image. Third is image similarity search. You give an image, that is image to image retrieval. You give an image, image gets converted to encodings, or we can say the vectors, and it will be compared to another vectors that are present in the embedding space, and it will be giving the best fit other image as compared to the input image. Third, the fourth one is rank. So what clip does is it tries to maximize the cosine similarity and gives the result which is the maximum. So for example, there are 5 images and you have the highest cosine similarity as 0.50 or 29. So in that case, the 0.50 will be prioritized and the best fit will be that one. The last point is fast semantic retrieval. So the clip works very fast as it just does the semantic search. So it is comparatively faster than other image retrieval models. Now, what clip cannot do? Clip cannot generate any descriptions or captions or any of the explanations for an image. If you ask, like, can you give me can you explain this image? Clip will be failed in that case. Then we have like why is there something unusual or dangerous in the photo? So that also cannot be done by clip. Next is clip cannot process any of the text, meaning OCR. So OCR is basically retrieving the text from the images, so, and using that text to and giving them to the model for parsing. So this is a most general use case of OCR. Then the last one is chain reasoning. Clip cannot do chain reasoning of thoughts and cannot reason on how the what is the analysis of the image or what image is exactly about. Yes. So now we will be diving deep into the architecture of GPT-4 vision. So it starts with giving an input image, then the input image is passed further to the visual encoders. What these visual encoders do, it will divide the image into different small patches. These patches will be given to the projection layer and where they will be converted to other embeddings. So it would be better understand if you bring up the next slide. Yeah. So here we have divided the images. In the second part, you can see patch extraction. So there the image gets divided into patches.
Further, it will be going to, it will be divided, converted as in embeddings or vectors, and then we will be having projection layer. Now, the main thing of the projection layer is it would be responsible for converting or mapping the vectors into the your LLM's embedding space. It is very necessary that we map our vectors, image vectors or text vectors as per our LLM's embedding space. So after that, the LLM will be responsible for all the reasoning part, all the patches that it has got, and it will be able to reason based on your image. Okay, so now I will be explaining like a basic thing, like what differences are there in CLIP and GPT-4V. So we have certain metrics such as architecture. First of all, CLIP is a dual encoder architecture. It has a image as well as text. Both encoders and decoders will be there in CLIP. Whereas in GPT-4V, we have a unified decoder with just a projection layer and a visual encoder. And it will be, it won't have a different what we say, an image and text encoder. It would be unified. Secondly, we have the training objective metric. So the training objective for clip is to just match the images or image with the text. Whereas the main objective for GPT-4 is to reason based or give the analysis of the image and make the prediction on image plus text sequences. Further, the output type. Clip would be having a similarity score which would be in a float type, and GPT-4V would be generating the free-form language. Further, can Clip generate text? No, it cannot generate text. Whereas GPT-4V, it can generate descriptions, it can generate captions, and it can explain images. Now we have the speed factor. GPT-4V, as explained earlier, is very fast because it just compares the cosine similarity. Whereas the main thing where my mistake, CLIP is fast because cosine similarity, whereas GPT-4V is a bit slower, we can say, because it needs to reason based on the image patches that it has got. Now the cost factor. Clip is open source, but GPT-4 requires an API key to be used. And Clip is best for classification, retrieval, and search, whereas GPT-4 will be best useful for analysis part of an image. Okay, so these are the real world applications that we can use Clip, cross-model retrieval techniques, and GPT-4V. First is fashion retail, visual style search. Second one, medical imaging, radio report drafting. So in this medical imaging, as Fanil explained earlier, that one of the model was specifically trained for having the medical imaging, we can say, properly diagnosed X-ray images. Then third, we have product listings and QC. QC means quality checks basically. So product listings explained by Yagna. Then we will be having threat detection and incident reporting. So whenever the threat is there, we can have the GPT-4 at that time, and it can reason like what next steps we can be doing on the go. Further, we have visual property evaluation and listing intelligence. And lastly, we have archive search and caption generation. Okay, now we will be proceeding for a demo. First, I will be giving a demo for GPT-4, which will be further carried by Panel and Yagna for their own particular models. Thank you. Okay, so here I will be uploading an image first. Okay, so we have our image here. You can see the image is basically related to the production units where we have 1,25,000 cans produced. Then we have the date range indicator. We have damage by stage, damage trend over time, and we also have some other factors such as damage by cause, and lastly, damage details, stage, and cause. So I'll be asking the model to summarize this image. It is basically a detailed image, and few of the companies don't go deeper into the uh, all over the images that are analyzed to save the time. So let's summarize this. It would take some time as it does the further reasoning and image extraction features. Okay, so here we have got almost all the things covered, like why, like how much percentage of the cans were damaged during the production or during retail arrangement, during factory production, and by customer. So all of those were extracted from the image. Some of the points are calculated by the model itself, based on the other indicators that were given. Then we have the main causes of damage, and lastly, it also gives us the percentage, like how much percent was the damage. Do you want to ask any further question to the model to analyze the image? Anyone? Okay, no one. Yagna or Fanny, you can please continue. Thank you, guys.
So here we will be getting the demo of cross model retriever. Uh, I'll be giving a text prompt where I'll identify what kind of object I want, say white shoes. So I have multiple images stored in my local space which contains multiple type of objects like laptops, earbuds, headphones, shoes. It has multiple colors of shoes, and here as we see that I have prompted white shoes, and it has given me most relatable images of white shoes, top 5 images, as we have given 5 top 5, and it is giving most matching image would come first as it has the highest probability, and least matching image would come as the last. As we can see here, we have five images. Similarly, if I have searched blue sports shoes, and we are getting images of blue sports shoes, and it all these images are stored in same space. It's not like we have saved different images in different folder and all. Everything is stored in one space, and it has found the images that are matching the textual question that we have given. Now, Yagna will explain you the demo of Clip 4V, GPT 4V, my bad.
Thank you, Fanny. So let's go and look at zero-shot classification using the CLIP model. Now we know that this model is trained, so we have not trained it, it's pre-trained, and we'll just pass two labels to it for the use case that we saw before. That was for a can. So let's pass an image, and it's trained locally and it's deployed locally as well. So we'll just give two prompts to it, and this might take time because it's on the CPU. So until then, we have other examples to see. So until processes. So these are some examples for the two types of classes that we discussed earlier. This is an image of a can in factory settings. So this is probably from a CCTV. So we can capture such images, from the cameras that are already present there. And this, without any training, it gives the classification label with the percentage. And if you want to train it on your data, which it's not possible that, it's not able to classify your image, you can train it on your data as well so that it suits your use case. and then you can check again. So this again is for the normal type. Okay, this is still processing. By the way, this demo was built using AI, and yeah, so this is the label now. It correctly gives the broken label which we wanted, and it will at the end will help us to identify which object is broken or defective, and then again for the normal case as well. So I'll hand it over to Dhairya to continue with the closure.
Hello. Okay. So what if now you want to build the same demo that we showed? Here is the tech stack that we used. We had the clip model from the transformers, basically the Hugging Face. Then we had used UI framework that was Streamlit. Lastly, vector math using NumPy, GPT-4 we calls that we had OpenAI, and deploy on Hugging Face. If you want to deploy, then there are spaces on Hugging Face. And build phases that were set up, install the dependencies. All the developers may be knowing like first requirements, pip install requirements, right? Then module 1, 2, and 3, and unified UI. And this is the most important part that you need to import, like from transformers, import clip model and processor. So what are the key takeaways of this session? First is the clip model. That was the breakthrough brought by OpenAI in 2021. It is using zero shot classification. Then we had contrastive pre-training. That means it pulls the nearest matching embeddings or vectors like together, and breaks or push apart the rarest match, or we can say the less near embedding vectors. Then we had cross model retrievals, and lastly we had GPT-4. Okay, so now if you want to go in deep for this, then you can review these resources. We will be sharing you, or you can connect in personal for us to us and get these resources, or you can take an image if you want. Done? Yeah, yes, we will share the PPT. Okay. Thank you, guys. Hope you had a good session. Thank you, everyone.
Q, Yagna, Dhairya, Fennel, that was really deep dive, I tell you, because since morning we are talking about AI, ML, GPTs, LLMs, okay, now at the end we shown, okay, that you've shown that what actually happens in all this infrastructure, right? So it was a full circle, I would say, okay, since morning to at the end. Uh, so we are almost at the end of our summit. The final thing which we are going to do now is we are going to have some quiz. You will see a question on the screen with 4 options, and I would request, okay, that anyone who is aware about the answer, okay, they can raise their hand, and I may pick someone, okay, and right answers. Our team has arranged some goodies for them, okay. So Means with the right answer, you get a chance to win some goodies. So,
अपलोड करवा दीजिए बॉस।
hello. Yes, we are ready. So, this is the first question. If anyone knows the answer, they can raise their hand. Yeah, that gentleman. Yeah, you. Laura. Okay. What is your name? Rutik. You can come over here. Okay, so that's it is low rank adaptation. Next question. Just give me a second. Okay. I'll go that side. No, I will not select you. uh, that guy in the middle. Yeah, you. Option C. How many of you agree? Okay, then it must be correct. Yeah. So, okay. Okay. Okay, you. Option B. Okay, there are so many high hands I see that they went down, okay? Okay, so I think that is option B itself. What is your name? Okay, thank you. So we are moving for our fourth question. That boy on the last row. Yes, you. B? Anyone who thinks it's B, they can raise their hands. I see more hands after he said it, okay? Okay. So even I believe it's B. Okay. What is your name, young man? Dhruv. Okay. Thank you. Fifth question. Uh, you, sir, in green shirt. Integrating information from different data types like text, image, and audio. Anyone has any other option? All hands down. Okay, then it must be correct, right? Okay. Okay, good. We are moving for next question. Uh, you. Yes, you. Yeah, yeah. Option A. A. Any other? A, she already said A. Do we have any other option? B. Okay. How many of you think it's B? Okay. Anyone for C or D? No? Okay. Then this is the right answer. Okay. Let's move for next question. Question number 7. It's very easy, right? Okay. You, sir. Yes? Okay. If anyone has A, C, or D, they can keep their hand raising. No? Okay. Then I think it's B it is. Okay. Okay. Next question we are going. Mm, that boy over, yeah, you. Option B? B? A. She is saying A. You are saying B. B? Okay, so we have A, B, B. Okay. Uh, right? So what was the? It's B, right? Okay. Then, Rutik, you are asking the name, right? Okay. Thank you. Question number 9. Do you want to answer, Ronak? Okay. Okay, so how many of you agree, Ronak? Ritesh, I will not pick you, any one of you, okay? Okay, not you, okay? Then, no, no, yeah, you. Option B. Okay. Because he asked the most questions as well. Okay, so I wanted to give him the chance. Yeah, so I think it's option B it is. Okay. Okay, we are having the last question of the day. Our HR team asked me to not give this chance to Prama team members. I'm sorry. You guys are having so many other exciting things, okay? Okay. Uh, yeah. I'll go over there. That girl over there on the last. Yes, you. Option B. How many of you think it's option B? Yeah. Even I believe it's option B. Okay. So, yeah, we are done with our question answer round. Thank you very much, everyone, for participating in this thing. And we are going to have the prizes for all the winners. So I want to invite all 10 winners, okay, to come on the stage for prize. Ronak, I invite you for gift distribution. Chirag, if you can join as well. Yep, please come on stage. Yeah, so we can, they are preparing for the gifts. Okay, meanwhile, if you can.
Heavy on that side.
Yeah. If you can have, we can have your name for everyone, what you do, sir.
Okay.
Okay.
So this is for everyone. I like Gen Z. Gen Z कहाँ है? सब हाथ ऊपर करेंगे. Okay. So बाकी जो नहीं है वो देख ले. This is our future. My name is Utpal Bidai and he has asked me to tell you what I do for living. So I make people happy and rich. How we can meet offline? Thank you.
Yeah, Raju, yes, I am owner of INS Tax Solution. Thank you.
I am Imansu Saha and I am stockbroker and property broker.
I am Preksha and I'm a data scientist.
Rakesh Sojitra. I'm working in Global as a senior software engineer.
Myself Hussein, I am an aspiring software developer.
Myself Kunsak, looking for jobs and internships.
I am Aks Konsagra, currently interning at Inaxa Solution as an AIML developer.
My name is Dhruv Pandya and I'm a student at Ganpat University.
Hi everyone, I am Jay and I am IT enthusiast.
I am a Priyal and working as a system engineer.
My name is Rinku. I am student for BCom Commerce.
So I really like that, okay, that someone is pursuing BCom, okay, they are attending Data and Summit. Okay, so I really thank you very much, okay, for your participation over here. Yep, you can go ahead and distribute the gifts. I can announce the names, it's okay. Yep. Jay? Hussein? Yep. Utpal? Yes? Raju? Yep. Rinku? Yep. Rinku. Yes, she is. Priyal? Yep. Preksha? Thank you. Kunj, Dhruv, guys, we need goodies for them. Yeah, yeah, we can do it. Okay. Yeah, 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 fine. Okay, so if you can, did we had group photo? Okay, thank you very much, everyone, and congratulations to all the winners. Now, on the closing note of our summit today, uh, I want to thank each and every one of you who had participated today in this thing, because when we see this many people interested in this kind of summit, okay, it gives us more encouragement to host this kind of summits more and more and share our knowledge with the community, whatever we get, right? So I thank you very much, everyone, that since morning till now, everyone is here, okay, and with this energy at the end as well, right? So at the end, we promise that we will come back with even better summit next year. That's our Prama and Phenomics promise to all of you. And follow us, okay, on LinkedIn for more insights. We share all the industry insights, whatever we learn from industry, from our clients, okay, whatever knowledge we gain, we share all of them over there, okay, so it will help you out in getting more insights before we meet in next summit next year, okay. And on last thing, for all the time and energy you invested over here, our team has arranged a goodies outside, okay. Our Avengers will help you to have that, okay. And I request all Prama and Phenomics team members to stay on the floor, okay, because we are going to have a group photo sessions and everything. So everyone, thank you very much again, and you can collect your goodies from outside. Thank you very much.
One more time? Okay. Thank you, Tejas, for being such a good host.
Oh, thank you.
On behalf of Prama and Phenomics team. It was wonderful. Thank you.